In only about 2 years, JetZero, the company behind this plane, planned to have it flying. Not a scale version of it, no, an actual full-size prototype, and it looks like they now have both the partners and the money they need to actually make that happen. But why? And also, if big names like Boeing, Airbus, Embraer and other established aircraft manufacturers aren't building something like this, then why would a startup stand a better chance of making it work? And also, who really is JetZero?
JetZero.
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 Now, it's been a while since I made a video about blended wing-body aircraft designs, which is what this aircraft is. Blended wing bodies aren't as extreme as pure flying wings because they still have a fuselage, but this fuselage still generates a considerable amount of lift and can also be aerodynamically stable, which isn't necessarily the case for flying wings. But the first question that we need to answer here is, why bother with this design at all? Why would an airline prefer a blended wing body over a tube and wing airliner that we all know and love? Well, the quick answer is efficiency. You see, the body profile of a platform like this can bring gains as high as 30% in aerodynamic efficiency alone, and some companies claim that they could do even more than that. Now, it is important to understand just how enormous that 30% would be. Usually, by far the biggest efficiency gains we've seen in modern airliners recently has come from new engines, not from aerodynamical improvements. When Boeing and Airbus, for example, put new engines on the 737 and the Airbus A320 to create the 737 MAX and the A320neo, they improved their efficiency by around 14 to 15%, which was a really big deal. By comparison, recent airframe-related gains are much less impressive. If you look at, for example, the brand new all-composite Boeing 787 with Rolls-Royce Trent 1000 engines, it's only around 2 to 3% more efficient than the Airbus A330neo, who sports nearly identical Trent 7000 engines, but with an aluminium fuselage based on the much older Airbus A300 design. Now, these numbers can vary depending on the route length and passenger count, but I think you get the idea. The engines have always been a much more promising avenue for efficiency improvement, but even the 14 to 15% improvement from the 737 MAX and the A320neo engines would only represent half of the improvement that a blended wing body design is promising. So that's why there are quite a few commercial and military operators that are really interested in designs like this. But here you might also ask, if blended wing body designs are so good, then why aren't all airliners built this way already? What's the catch? Well, as it turns out, there are quite a few of them to choose from. An obvious one has to do with airports, specifically with airport gates. At the moment, those are designed for the relatively long and narrow airliners that we know today, but blended wing bodies will be shorter front to rear and wider, which could put them beyond the size of typical airport gates for single-aisle aircraft. Now, this could be overcome by giving these planes folding wings, which has already been looked at by JetZero, but probably won't be a feature, at least on their prototype. The next problem is pressurization. Conventional airliners have had tube-shaped fuselage even before pressurization was a thing, since that shape is both strong and lightweight. But as it turns out, a tube is also ideal when we want to turn it into a pressure vessel. It's no coincidence that oxygen or nitrogen gas cylinders or fire extinguishers usually have this shape as well. But with something like a blended wing body, the passenger cabin and cockpit have a much more irregular, complex shape, and pressurizing that would therefore historically require more material to allow the fuselage structure to resist the internal forces and retain its form, and also to avoid developing cracks over time from metal fatigue. Fortunately, new carbon composite materials are now helping a lot with this. When made and shaped properly, composites are a lot less prone to pressurization cycle fatigue than the aluminium alloys that most airliners are made of, and therefore allows for more complex shapes to be made relatively easy. But these complex shapes also create a different problem. When the plane's fuselage is just a tube, a manufacturer can easily build differently sized versions of it basically by just adding slices of fuselage in front and behind the wing. Well, there is of course a little bit more to that, like extra emergency exits, but that's also relatively straightforward. That possibility to vary sizes is crucial because when airlines add a new aircraft type to their fleet, they usually also want a few different sizes in order to fit different roles and routes. And since those variants are more or less exactly the same aircraft, just differently sized, this then eases training for pilots and engineers and makes crew swaps easier when needed. But how do you accomplish any kind of variability in size with a blended wing body, where each size version requires its own set of jigs and molds to shape the composite structure? That would mean different production and assembly lines for each new variant, which would complicate manufacturing and push costs way higher. Well, initially, the cost to make these composites would be high anyway, but this is where JetZero's plans for their blended wing body design starts to get really interesting. The company has issued a patent numbered US 6,708,924B2, if you want to look it up, and that patent addresses a number of blended wing body challenges. You see, even though the fuselage and wings will have nice smooth lines when finished, the plane is actually put together like a Lego toy made out of bricks. The patent shows that the passenger cabin will be made out of rectangular sections running front to rear, with each section having a door at the front. So to make aircraft of different sizes, sections like these could then be added or removed or swapped out for different ones. So to vary the sizes, JetZero would simply make the necessary sections separately and then bond them together in the right combination for the desired size. This method also helps address another issue with blended wing body concepts, which is the number and placement of emergency exits. In an emergency, we want people to be able to evacuate the aircraft safely even if half of the available exits are blocked. And because of that, available exits should be spread out and they should be placed as evenly across the cabin as possible. Now here the doors are towards the front, but the width of the cabin means that even those seated in the back aren't too far away from an exit. Now I should add here that patent drawings must always be taken with a little bit of a grain of salt, because they're designed to secure a process without giving away anything more than absolutely necessary, which can make them quite misleading. But in this case, we at least get an idea about how such an aircraft could be feasible to produce, again, thanks to modern composites. But I still haven't talked about JetZero, the company, and why we should believe that they can actually build this, which I'll get to after this. I just want to take a quick moment to thank today's sponsor, Opera, one of the absolute smartest browsers in my opinion. And I really want to show you their newly updated version, which has made my day-to-day workflow much smoother. If you've been following me for a while, you know that I'm a multitasker, so one of my favorite features in Opera's latest version is the split screen, where you can have two tabs open side by side. This is perfect for when I'm researching accidents, for example, or when comparing two separate articles side by side for a script. No more juggling multiple windows or setups. And also, check this out. If I run into a question mid-script, I can just hit Ctrl+/ or Command+/ and ask Aria, Opera's built-in AI tool, right there on the page. Aria can also generate images based on a single prompt, or the other way around, you can upload images and Aria will tell you more about them. Really cool. As someone who always tends to have loads of tabs open, the Tab Island feature is another lifesaver, where you can group and collapse tabs by topic, keeping things clear and organized. There's also a floating music player, which I can move around and control music from 7 different streaming platforms without interrupting my browsing. And all in all, Opera just really feels more like a personalized workspace than a browser. And do you want to know the best part? Opera is completely free. So if you want to try it out and also support my channel, then go to the link here in the description. Thank you, Opera. Now let's continue the video. Now, again, if we look at JetZero, what is it that speaks for this company being successful in creating the first ever commercially viable wing body design? Well, first of all, even though this is obviously a startup, their people are not new to the industry. Mark Page, JetZero's chief technology officer and one of the two founders, has worked in aircraft design roles for both Boeing and Douglas before that. He was actually part of a joint project between McDonnell Douglas and NASA for the development of a blended wing-body aircraft already back in the 1990s. The other co-founder and CEO, Tom O'Leary, has worked for Ford and Tesla, among others, and other key people in the company have had engineering and other positions in Boeing, Airbus, Embraer, Bombardier, Safran, Rolls-Royce, General Electric, Gulfstream, Northrop Grumman, SpaceX, as well as Spirit AeroSystems, among others. Their expertise also includes people with experience within airlines like Delta and Qatar Airways, and even from the lesser AerCap. So that's a broad range of people with aviation backgrounds, which we don't always see at ambitious new companies like this. JetZero has also announced partnerships with Pratt & Whitney for its engines, which I'll get back to shortly, as well as Collins Aerospace for the engine integration. For other key systems, they will work with companies like BAE Systems, Safran, Thales, and other well-known names in the industry, which will be absolutely crucial for its success. Now, all of this talent and partners obviously need funding to put together an actually flying aircraft. And as I mentioned briefly in a recent video, JetZero has actually secured a contract worth $235 million from the US Air Force to construct this full-scale demonstrator aircraft. The reason the Air Force is interested is because a design like this could be useful either to transport people and materials or as a tanker for air refueling, which the Air Force refers to as the next generation air refueling system, NGAS. For the military, a blended wing body has an added advantage as well, because it has a relatively small radar cross-section, since its underside has few inside corners and its engines sit above the actual fuselage. But whilst $235 million is a decent sum of money, it really isn't close to what's needed to design and develop a new airliner, especially such an unusual one. According to John Ostrower in the Air Current, who are keeping track on this project and who you should really check out if you haven't already, JetZero will need $7 to $10 billion to develop a production version of this aircraft. Now, JetZero does have more funding from other investors, including some of its industrial partners and from airlines like United and Alaska Airlines, but for now, their total funding, including the Air Force's contract, sits at just around $300 million. But I did say earlier that this aircraft was going to get built, so how will they do that with only a fraction of the needed budget? Well, as you might have noticed, I earlier referred to that first aircraft as a demonstrator, which was a bit of a clue. You see, the first aircraft that companies like Boeing and Airbus make when they launch something new may undergo small changes during development and certification, but they are largely built to a production specification. So that means that many of these development jets actually end up joining airline fleets when the testing is done. But by contrast, JetZero's demonstrator will be an old-fashioned prototype, similar to what Boeing did in the 1950s with its 367-80, better known as just the -80, which was a prototype for the mighty 707. Incidentally, Boeing's first customer for that old demonstrator was the US Air Force, because it was also the prototype for the KC-135 tanker. And now, the JetZero demonstrator could become the basis for the Air Force's next tanker, which has a nice symmetry to it. Now, the company that will actually build this first airframe is the famous Scaled Composites. And if you haven't heard of them, or their founder, Bert Rutan, you might want to spend 5 minutes looking at all of the crazy projects that they have put together over the years. The Spaceship One experimental spacecraft was theirs, for example, and if you think that JetZero's plane is much bigger than that, which it is, well, it's not as big as the Stratolaunch carrier aircraft, another Scaled Composites project, and they today form part of Northrop Grumman. JetZero has already also built a simple cabin mock-up to show its potential customers what this unusual configuration will feel like. There are multiple cabin sections who look like side-by-side single-aisle cabins who open up in the front. And I am really looking forward to see how that works for those sitting away from the windows. JetZero's approach is intended to allow the build of a prototype relatively quickly, showcasing its potential to partners and investors, while still helping to reveal any weaknesses that they might find and other areas that might require more attention. And that's where the experience of the company's people and its industrial partnerships becomes really, really important. You see, since this plane will not be in the same specification as the production aircraft, it doesn't really make a lot of sense to spend crazy amounts of money to develop bespoke systems for it. As the Air Current explains at length, JetZero is choosing components using the commercial off-the-shelf or COTS approach, which means that they will use parts that are already in use by other aircraft. But in this case, it is a little bit more complicated. Usually, the COTS approach works when a company wants to upgrade a few systems in an existing design, or when building something relatively small. But designing and building a complete airliner-sized one-off aircraft with millions of parts is a different cup of tea. You see, a lot of aircraft systems need to talk to other systems in order for them to work properly. So JetZero needs to choose those systems carefully, especially when mixing parts from different suppliers, which is inevitable. For example, JetZero wants the plane to have active side sticks, which I think is a great idea. So they are sourcing these side sticks from BAE Systems, who already make them for Gulfstream's newest business jets. That means that they also have to use a flight control computer made by Thales, who supply those computers to Gulfstream. Now, details like this might sound simple, but the difference between developing something bespoke or buying something that already exists applied over the whole aircraft could mean the saving of hundreds of millions of dollars. Other examples of mix and match aircraft systems for this demonstrator include main landing gear from an MD-11, the nose gear from the 757, a lot of avionics from Garmin, the throttle quadrant from a Boeing 787, and rudder pedals, flap and speed brake handles from the Gulfstream G650. But that commercial off-the-shelf attitude becomes even more crucial when it comes to the plane's engines. Except that this time, this could also affect the future production aircraft. For the demonstrator, JetZero has chosen an engine that's well known and tested, the Pratt & Whitney PW2040. That's the engine that powers many Boeing 757s, and its military version, the F117, currently powers the Air Force's Boeing C-17s. This is a 1980s engine, which has seen some updates over its service life, but is lacking some modern features like Full Authority Digital Engine Control, FADEC, which is basically a computer that constantly monitors and directly handles the throttling of the engine based on what the pilot asks for. Now again, I am talking about the test aircraft's engines here, so anything that's reliable and available and has the right amount of thrust and weight should do nicely. And in this case, Delta Airlines has kindly given over 2 PW2040 engines to JetZero, plus a third one as a spare. But there is an extra twist here, and that is that, according to John Ostrower, JetZero is also considering a version of the same PW2040 engine for the production version of its aircraft. And that doesn't seem to make much sense, does it? If they do that, you have to remember that when this aircraft enters service in the 2030s, that engine design would then be over 50 years old. Now, Pratt & Whitney would modernize the engine a bit for such an eventuality, integrating a FADEC system plus newer combustors and other systems that would improve efficiency slightly and reduce emissions. But still, how does this make any kind of sense? Well, first of all, remember here that the first customer for this aircraft could well be the US Air Force. And they seem to be very happy with the engines on their C-17s and their military 757s, and they have already built a supply chain around them. Theoretically, an upgraded PW2040 could eventually be used to upgrade those C-17s, but that's probably not a factor in JetZero's decision. Now, another reason here is that the airline industry is now getting a bit fed up with the troubles that brand new engines are currently bringing. We have previously here on the channel looked at the longevity and development issues with Pratt & Whitney's geared turbofan engines, longevity problems with some Rolls-Royce widebody engines, a need for more frequent maintenance for CFM's LEAP engines, as well as supply chain issues and delays for basically all of them. A lot of new engine and aircraft designs have entered service in the last 2 decades, and many of their operators are now longing for some stability. The air current calls this new technology fatigue, and other analysts like Scott Hamilton in Leham News have identified this same trend as well. As Gus Kelly, CEO of Lesser AerCap, said recently, "Please don't come in here and tell me you're going to have another swing at a new design. I want the stuff you've built to work better." Now, in a recent video, I mentioned that Rolls-Royce is now developing a smaller version of their UltraFan demonstrator, and that this engine could be ideal for the JetZero production aircraft. Rolls-Royce does indeed seem to have offered such an engine to JetZero, and Pratt & Whitney also offered the PW1000G geared turbofans to the company in addition to that updated PW2040. But JetZero's mindset on engines has become more conservative in recent months, mainly because of that feedback from airlines and lessors. Basically, when it comes to a design as novel as this one, the airlines seem to favor an engine that's as small of a risk as possible. Better the devil you know, as the saying goes. Now, this creates an inevitable dilemma though. JetZero will eventually want to offer a second engine option to its customers, which could indeed be a more modern engine, maybe with a geared fan. But that could then punish first mover airlines who chose to buy the first couple of aircraft with only the older technology engines available. But to be perfectly honest here, even if that might eventually become an issue, that's way into the future. The company hopes to fly its demonstrator in the first half of 2027, and as I already said, that first customer could simply be the US Air Force, especially if JetZero ends up getting much higher value government loans for the development of their production jet, which could become a key factor here. So, what do you think? Would you want to fly in an aircraft like this, and do you see any issues? Let me know in the comments here below. Also, tell me if you want me to try and interview someone from JetZero or Captain Speaking podcast, which I hope you have already subscribed to. We haven't started doing interviews there yet, but we could do so if you want us to. My name is Petter Hörnfeldt and you're watching Mentor Now. Have an absolutely fantastic day and I'll see you next time. Bye bye.